Good day. In the last video, you learned a bit about percentage error. You get a reminder of it right here. This is a sheet we're going over. It should be in your notes package. It's not an assignment. And every so often, you'll run into questions that want percentage error. And if you're in physics, it may be more often. We don't run into it very often, but enough that it is convenient to look at this. So let's see if we can find the sheet we're going over. So here is how to tackle these questions. We're given an experimental and accepted value. So what we want to do is find the difference between these two terms. So accepted value minus experimental value, and then we have the absolute value sign, so we don't care if it's plus or minus in this case. So you can very quickly see it's going to be 0.06 divided by 1.30. And that means we get a percent error of 5%. So once we have that ratio, to make it a percent, you just multiply by 100 and tack on a percent sign. And we're applying sig figs. Say 1 sig fig, 1 sig fig. So we're given an experimental value, an accepted value. And it doesn't matter. You can punch them into your calculator like this, or you can expand them out. So we plug in those numbers. Boom minus boom divided by bam. And in this case, we get a 20% error, 1 sig fig, because we get limited down to 1 sig fig there. So it becomes a pretty straightforward game. 252 versus 225. So we'd say that doesn't look very precise. So we do our subtraction, we get a negative value. We divide by our 225, absolute value says, hey, make it a plus. And it becomes a 12% error. And again, pause if I'm going too quickly. This one is pretty tiny. 0.2 versus 0.4 out of 22.4. And so we do our division, we get 0.9%, less than 1% error. That would be very nice. And this one's pretty good too. Again, boom minus boom, again we're dividing by 124.8, and we get our accepted value. So those are 5 examples. Just to file away on the occasional lab, you're likely to have to do the odd percent error.